If you're a seed producer, a comprehensive set of sieves can be invaluable for cleaning and sorting your seed, but in the UK these are surprisingly difficult to source. Finding the mesh itself is actually far easier, so at the Wales Seed Hub we decided to make our own sieves and were kindly funded by the Gaia Foundation's Seed Sovereignty programme to do just that. We're now sharing our Beginner's Guide to Sieves, which includes a PDF doc with details on how to decide what materials you need and where to source them, as well as this video on how to make the sieves themselves. We've used both woven mesh and perforated metal plate for our sieves, with a variety of hole size. Although available in different materials, we went with stainless steel for everything. This is much stronger than aluminium and, unlike mild steel, won't rust. As our sieves will be used by hub members around Wales, they're going to be frequently transported and kept in a variety of conditions, so this durability was essential. So when our metal arrives, if it's not the size that we want it, how do we then go about getting it to be the right size?
Right, well, when we've decided what size we want our sieves to be, we mark out the size on the metal. As accurately as we can. So I've decided these want to be 500 by 250. That is the same size as all their sieves we've built, which is the same size as this already is. So when we come to cutting it, you can cut it with, if it's mesh, the best way to cut it is with tin snips. You can buy all sorts of different tin snips. It's very simple and straightforward to cut. With perforated sheets you will not get through it with these. You will need to use an angle grinder, and the next stage I will show you how to cut it. Because this is stainless steel, do not try cutting it with a jigsaw. You will just end up blunting your saw. I've tried it, it doesn't work. You'll need to use an angle grinder with a cutting disc and wear safety specs. And it's done. So when your mesh is cut, you need to mark out a drawing, because you've got to get your wood pieces very accurately sized. So on this representation here, this black line represents the size of the metal. I have then allowed a gap here which is the size of the router piece that you'll be using to recess for the metal to sit in. So I know that because this ball bearing here is replaceable, I've gone down to a size which gives me 9.5 millimeters of cut. So this line is 9.5 millimeters in, which tells me with my thickness up that I know that the wood is, which is 27 millimeters. By marking everything accurately, I can give an exact to the millimeter cut length for all my pieces of wood.
So why have you gone with 27 millimeters for the size of wood? It looks quite chunky.
It does. That is the wood. It is quite chunky. I want that to be very sturdy. The sieves are going to get bashed around a lot, and also you need to be able to screw through onto this piece here, but avoiding going into the metal. You cannot screw into the metal. You can't drill through the metal because it's stainless steel. If you try to drill through the metal, you will just burn out your drill bits. and if it's the mesh, it will push the strands apart and you'll end up with gaps in here. So your screws have to go on the outside of the mesh into the wood, and if your wood is too thin, it doesn't give you any leeway to screw into. So these holes are fractionally offset from center to give me plenty of room for the screws to go into here and hold the wood down nice and tight.
Could you not just make your 9mm recess bit a bit smaller and use smaller wood?
Theoretically, yes, but in reality, I'm dubious that it might not be able to be pushed in the center and therefore spring out of the frame. You do not want it springing out of the frame. It's got to be in there. So if you've got maximum amount in, I know that it's going to be, I'm fairly confident that it will be secure and safe. So we start out with plain sawn timber. It's nice and smooth surface so that the seeds don't get stuck on it. And originally it was slightly wider, but I've stripped it down into the two component parts, the base frame parts, and as you can see they're slightly different lengths. These are designed so that when this goes onto the frame, these screw holes on the end go into the side pieces. So we need all of our cuts to be very accurate and square, so you need to use something like this, which is a miter saw. Now you can buy miter saw boxes like this, they're a lot cheaper. This one is actually too small for this, you can get bigger ones. Or you can use a chop saw if you've got one, access to one, but this is what I'm using. Now, because you know your length already, because you've got your design, you can create a stop block on your frame, which will give you an exact measurement that you can just constantly repeat. So this wood can just be fed in, cut, for all your pieces, all in one process. When you come to the smaller or different size pieces, then you simply move your stop block to whichever length that piece needs to be and feed in. So that's all we do there.
That all seems quite complicated. Can I not just use a hand saw and a tape measure?
You could, if you were just doing one or two, then that might well be a quick way of doing it. But these cuts have to be very accurate, because if they're not accurate, then the metal doesn't have any leeway in it and it will not fit together properly, and it will give you problems down the line. And unless you're very skilled at doing it, and I'm so-so, I can't get a very good straight line. I know that my lines will be slightly off, so
it's worth just buying a...
It's worth doing it properly. So, to make life simple, I clamp this on. And then simply cut it to length. So when you've got all your pieces ready, you've got your long sides, your short sides and your base pieces, you need to drill a few holes in them. So for the base pieces, I have set up this jig here with a stop block on the back to give me the hole position, which, as I said earlier, it needs to be just off centre, and I've marked some lines on here to tell me where the end piece ends, so that I know that that hole is always constantly at the correct position. So I've just marked a little line on here in order to drill it. these holes are not important in the centre ones, they're just to hold the thing down. It's only the end ones that are important in their positions. So that's all you need to do with that one. With the sides, the way this is set up, I need to drill 4 holes into the sides also to fit them together. Basically it's pretty much the same process. That stop block is exactly the same position for these as well, and
So do I need to use a pillar drill like that? Can I just use a hand drill?
you could just use a hand drill, but if you have access to a pillar drill, it's a lot easier to give it a very accurate straight drill. If you are drilling by hand, most people, me included, will drill off in one direction or another. It's very difficult to get a dead straight 90 degrees drill just using a hand drill. So if you've got access to a pillar drill, that's the best way to do it. If not, you'll just have to do the best you can.
Is that pillar drill one you've just made yourself?
This was one that I acquired from a car boot sale. It's just an old drill and an old stand as 2 separate ones. But the jig is all made by hand. So after you've drilled the pieces, I countersink them so they look a bit like that. The idea being that the screw head not only sits flush within the thing and you can't catch yourself on them, but also means that you get greater penetration into the wood below for the screw, and you're not likely to damage the wood by splitting it with the head forcing in. So I'm using a countersink. In this case it's on an old drill bit. There's all sorts of different countersinks you can use. This just happens to be one that I've got. So all I do is decide which I want as my inside face, which is the smoother surface. In this case they're both the same. I like that surface inside, so I will countersink on the outside. And that's it. You just do that to all the pieces you've drilled. Now for the fun part, which is assembly. Now, in order to assemble all my parts, I have created this simple jig. Now I've used a piece of old melamine, which was, I think this might have been a cupboard door or a piece of shelving furniture or something. I'm not quite sure what. But the point is, it's machine cut with a very accurate 90 degrees, which means that I can clamp to this and know that my sieves will be 90 degrees. So all I've simply done is dismantled the thing and used the base, the known square, and I've fixed the sides on here on 2 sides, which gives me an absolutely, and I've double checked, accurate 90 degrees angle. So this gives you a nice good start to everything that you do from now on. So all we now do is position our bits of timber within the frame that we've created. And the one step that we do need to do here is make sure that all of these pieces are exactly the same height to each other. Now there is a reason for this. It comes to routing out the next stage. If they are raised or lowered to each other, your router will not follow the contours properly. So everything has to be absolutely level. Now that one is a fraction off. So all I've done is got a various pieces of thin stuff. In this case it was an old label. I can put that underneath there and see if that makes that the same height. So that's too high. A piece of paper instead. That's much more accurate. That's much better. Same on that side. Looks like it needs something nice and thin also. Another, oh, that's a thin label. Try that in there. Yep, that makes that nice and level. And that's level. And that was level which is very handy. So now I can clamp this to the frame on two sides. At 90 degrees. And I'm using 50mm screws. They're 4mm thick, and all the drilling that I've done earlier was at 4mm thickness, so I know that these will pass nicely through without jagging the metal. Now we'll show you a shot of this later, which shows you the design on the end here, where I have made recesses for this screwed driver to go in, so that you can put the screws in, because obviously if you've got a big frame here you can't screw through the frame, so I've had to cut holes into the frame. And then that side gets screwed on exactly the same. So the next process is to route this piece here out. Now I'm using a router bit that looks pretty much like that, which is what I was explaining earlier. Now I have made this simple-ish internal jig so that when I am routing, the router sits neatly on there. If you don't use that, you can do that while you're routing. It's very easy to be inaccurate. So if you've got something like that, you can route with confidence all the way round. The important thing to do is to make sure that your jig is not sitting higher or lower than the piece that you want to route. In this case, we are very lucky it is actually the same height. In theory, if all your wood's bought from a good supplier, it should all come at the same height. If it's not, if there is a disparity, again you can just use various little shims to raise one or the other of the boxes up so that they are the same level. So at this stage, where you need to put on a dust mask and safety specs. So we have our basic frame routed down. Now I've set the router depth based upon the thickness of the wire that I'm putting in here. I know the thickness of that because I've checked it with a set of verniers and I've also done a prior cut with this as a tester to see what depth it is. It's always best to set the depth on this less deep than you require and test it, and if you are not happy with it, increase the depth, because obviously you can take more off, you can't put it back on again. So we have routed that out round, but as you can probably see or imagine, the router bit has left curved corners, and the metal that we cut earlier has square corners. I don't want to be cutting the metal down again. What I want to do instead is to just nip out these corner pieces with a chisel to give me the correct dimensions. And it's pretty straightforward, it's pretty simple to just take a little tiny piece out of the corner. So the next stage is installing the wire mesh into the recess. Now I want to keep this piece in the middle because I want to be able to have stability on my mesh. I don't want to be distorting it while I'm putting it in. So what I will do is put a couple of small shims underneath the outer bit, which is our actual sieve box. This just ensures that this recess is now the same height as this piece here. So there's a slight gap there, so I'm not forcing the wire up when I put it in. So the wire now fits inside my little recess. Hopefully, yes it does. And then, because it's a wire, these ones I will add a few staples onto to make sure that it doesn't pull out in any directions, because they're obviously slightly more flexible than the perforated sheet. So I can use the frame of the inside to support my stapler when I'm stapling. And I just do that all the way round. So now we're putting the base pieces on. Now, as we probably mentioned, I hopefully mentioned earlier, I've made these slightly longer so that that end screw screws into this piece and therefore helps to lock the sides all to the frame. So I will line up this side first and screw it down. And I'm using 40mm screws, the same 4mm thickness as my other screws, so all my drilling things are the same, but they do not need to be as long as the screws through the sides. Now I simply use these two as a quick guide to tell me where to put the last piece on, because I don't want that to be too far in. I don't want to squeeze that in later. I'll put that on there, and then I'll screw that side down and those sides down, and then that process is finished. So now we can just remove it from the frame and it is pretty much finished. You can leave it at this stage, but we do one extra process, which is to smooth off the edges with a router piece, just so that you've got a smoother edge to hold when you're using it. There's no reason why you have to do that, I just prefer it like that. It's just more comfortable to use in your hands. So again, safety specs and dust mask. repeat the process for the outer part of the frame, and I do it to the sides and just a little piece along the bottom there where your hand is, and that just leaves a smooth edge, which when you're just giving it a little final little sand feels really nice and pleasant in your hands. And this is a very simple rounding off bit, it just has an opposite curve to it, to that.